Differentiation is going to be our substrand. Now, differentiation is the reverse of integration. As you can see there, we have that function y is equals to x raised power n. And in this process, we just find the derivatives. The y over dx is equals to n times x raised power n minus 1. That is the function for the derivative of a function. Examples of the question which can be set in our exams. We have one example there which was set in Kcse 2003 paper 2 number 21. The questions demands us to find the coordinates of the curve y is equals to x cubic minus 3x plus 2. Are there now A, stationary points, B, determine each of the stationary points, whether at that point they are maximum or minimum. C, sketch the graph for the function y is equals to x cubic minus 3x plus 2. D, the last question, determine the equation of the tangent and the normal to the curve at that point. The point which you are being given there is negative 2, 0. Now let's go to solution. We have to find the derivative of the function x cubic minus 3x plus 2, of which we are going to use this our formula of the derivative of the function. So we're going to say that this 3 you take the other side, minus 1 also there up, so it's going to be 3x squared. Now derivative of 3x, this x here we have 1 minus 1 we have 0 raised power any variable raised power 0 is equals to 1. Now that 1 times 3, that's why we have 3 minus 3 here. And then for the derivative of a natural number like 2, the answer is equals to 0. Now the derivative of 2 is equals to 0. Now the function that we have there, our derivatives, the y over the x is going to be 3x squared minus 3. The first question said for us to find the stationary points. Now, A, coordinates of the turning points, also called stationary points. After finding the derivative as this one, 3x squared minus 3. So 3 here is the highest common factor into brackets x squared minus 1. This function gives a quadratic function of which we're going to use quadratic identities x squared minus 1. That's why we have x minus 1, x plus 1 is equals to 0. X minus 1, you take the other side to be positive 1. X plus 1, the other side to be negative 1. Now let us see, when x is equals to 1, substitute in the original function. So these values of x, 1 and negative 1, we are going to substitute them in the original functions of that particular equation. Now let's see. Now use that one, substitute into this equation. Whenever you substitute positive 1 into this function, you're going to get 0 as the value of y. Now the point is 1, 0. What about x equals to negative 1? When x equals to negative 1, substitute into this original function, you're going to get that y is equals to 4. Now the point is negative 1, 4. Question B says, determine each of the stationary points whether at that points they are maximum or minimum. Now, maximum or minimum, let us say at a point 1, 0. So we are just going to use 1 at the center here. We have the first row, second row. Now, the first row having those numbers, the second row having the y dx. The y dx is of the function of the derivative 3x squared minus 3. Now, you start from 1 in the mid row, you move to here or 0 here, and then use these x values, substitute into the derivative function. When you substitute into this derivative function, you're going to manipulate these particular values. Now, at this center, we are going to have a baseline. So, as a student, for you to score this question, you must look at from what's happening from negative 3 0 to 9. Now, you start from 0. When you move to 9, it means that it has been increasing. Now, starting from the base like this, you move up. The other side also, you must move up. You must also move up. Now, so at that point, the minimum point is going to be 1, 0. And let's see what happens at the x when x is equals to -1. Now, you also come here, 1, -1 at the center, -2, 0. So you're going to have, you substitute these values into the original function, the function of the derivative 3x squared minus 3. So you substitute there, you find this particular number, and then our baseline is going to be like this. Now observe what's going to happen from you come here from 0 to -3. So from 0 to -3, it means you go downfall. Now you can see it moves like this. So at that point is a maximum, and this point is a minimum. So for you to know the maximum or minimum, you can see this curve when it moves like this, minimum. When it moves like this, it is called maximum. Now, it is good for us to find the stationary points. So those are the points that we are going to use for plotting of the graph. Now, this point and this point are the one we are going to use to plot our graph. Now, let's go and plot our graph. So we plot a graph of the original function y is equals to x cubic. Let's bring that our graph there, the function that we're going to draw. X cubic. So we can also have there minus 3x plus 2 to see our graph. Now that's our graph. Yes, you can see that's our graph. Now for the stationary points there, we have a -1, 4, as you can see from here. The maximum point, -1, 4, and then the minimum point, this one, is 1, 0. Now, you find most of the students are drawing this particular function of this curve. No, you should not draw this curve. Now, why? Because whenever you draw this curve, it's going to appear like this. Y is equals to 3 x squared minus 3. Now, let us see the difference. As you can see, the function which is in a black has one turning point, whereas the one which is in red has 2 turning points. This one, and we can also have another turning point here, 1, 0, and we had there this one, we had -1, 4, 2 turning points. So you must not use the function of the derivative to draw that function. Now, that's why you are going to use, we have to do the derivative of this function. We have to do the derivative of this function so that we can find the turning points, of which we are going to have 1, 0 and -1, 4. Those are the points that we're going to use to plot that line. Now, this one, for the 3x squared minus 3, this cannot be used in drawing that graph. So we remove it. Come there and remove it. It's not supposed to be there. And the next question says, equation of the tangent at that particular point. Now, for the tangent, the y over dx equals 3x squared minus 3. Gradient, you're going to use this negative. Let's come down and give it a good color. Can use it. You can use negative 2. This negative 2, we're going to use that negative 2 to solve into this particular function to find the gradient. Now, whenever you use that negative 2 to this function, the gradient is 9. Now, whenever you have a general point and a gradient, you can find the equation of that line. So to be y equals to 9x plus 2. Now, let us draw that tangent at the point they have said negative 2, 0. You can go to your graph and say y is equals to 9x plus 2. Let's go and establish 9x is come there. 9x plus 18. 9x plus 18. So there was an error here in writing. So that's at the point negative 2, 0. That's our tangent that we have drawn. Now another question says the equation of normal to the curve. Now normal to the curve for the equations of a straight line, m1 times m2 is equals to negative 1. So 9 times m2 is equals to it's going to be like the reciprocal, negative 1 over 9. We equate, cross multiply. The kind of equation we're going to get y equals to 1 over 9x minus 2 y. So you can also draw that graph so that you can confirm y is equals to you say it is negative 1 over 9, negative 1 over 9 x 1 over 9x minus 2 over 9 minus 2 over 9. So come and establish your graph. So as you can see from there, this line, this particular line, let's give it a good color. You can give it blue. This line in blue is perpendicular to the line which is a tangent here. Now at this particular point, negative 2, 0, we have established our equation of the straight lines to the curve. So that's how you solve that particular question. Thank you for watching. Subscribe for more mathematics lesson.